So we were discussing different hash functions. For example, uh, these different hash functions which are used by a user to apply some integrity to the data. Now, now we discuss about different hash algorithms as well, which are used to be applied on some data. And when they applied on some data, they produce some hash value from those. And when it is created from uh, when it produces some hash values, so it produces a hash value, and then at the receiver end, that hash value is compared with the message from with the original message. When it is actually same as that of the original message, that means the data has not been changed. For example, if it is different from the original message, that means the data has been changed. So in this way, we can apply different functions on that. So we can have different algorithms which are applied to be used by that particular system. For example, uh, uh, we have such type of different algorithms. Like for example, we have MD4, MD5, SH1, RIPE MD160. So these are the different algorithms which are called as hash algorithms. And why they are called as hash algorithm? Because they are using they are applying the the technique of the hash value when it is applied on some message. So it creates a value from that, and when it creates that the value from that, that is received by the receiver, and then it is compared with the original message. When it is the same, that means the message is not being modified. So in this way, these algorithms can use and different types of semantic encryptions like DS encryption or AES encryption. So we apply these different methods and these different techniques to be applied on the user, on the data, for example, which is actually called the semantic encryption. So when it is applying that on some data, so that means the data is uh, that is received by the receiver. For example, it's having the same value. For example, that means if it is having the same value, that means the data is not being modified. But if it is having a different value, that means the data has been modified. For example, we have different algorithms, like as we have MD5, for example, that is designed by the Ronald Ravest, um, that and that is latest version of the MD2 and MD4, and this algorithm produces a hash value from a message, and that hash value which is produced from the message, and that is of length 128 bit. When it is produced from the hash value, when it is produced from a message, so it is again compared with the original message. When it is the same as that of the original message, that means the data has not been modified. So if it is a different, that means the data is being modified. So in this way, we have different messages, different types of messages which are used by different types of algorithms which are used by the user to be applied on the data in order to protect the data from an unauthorized user, so that an unauthorized user cannot access the data, or if he is for example, he if any change is done by the intruder or an attacker, that is identified by the receiver using these different algorithms. So these different algorithms which are used by the intruder and which he has applied on some data uh, where where he has applied uh, different functions on the data. When he is applying these different functions on the data, and when that is received by the receiver, so it verifies that if it's the original message which has been received by the receiver, if it's the same, that means the data has been not modified. So in this way, the MD5 algorithm has different features or different functions, different you can say parameters. Like for example, it is applied on the message that is of 512 bits length, and it uses a you can say a value 448 value to be applied on some message of 512 length, or some messages added to the original message that is of 448 bit length. And then when it is applied on that some function or some message, so it creates a value, or it creates a hash value from that is of 128 bit, for example. So it is applied on some value that is sent it from user A to user B, or for example, it is applied on some block of data. For example, here in this case is of 512 bit length. So when it is applied on that block, for example, so then it is received by the receiver, and it verifies that that block. So when it is the same as that of received, that means the message is not being modified. So in this way, we can further discuss the MD5 using this figure as well. For example, there's a message which is used here. There's a, for example, there's an original message here. We divide into different blocks of, like for example, 5 to 12 bits of length, and we apply you can say a hash function on that block, and then it produces a hash value from that. And when it is producing that hash value, then we compare that hash value with the original message. When, for example, that hash value it is the same hash value which is created by the original message, that means it's you can say we say that the data has not been modified, or the data is not being changed, for example. So in this way, we have this algorithm is working on the data block, or on the message, or on the block of the data that is of 512 bit length, and it creates a value of 128 bit. And when that hash value is created, it is compared with the original message. And when it is compared with the original message, so if it is the same, that means the message has not been modified, or message has not been changed. Now in the same way, we can apply different comparison methods also. Like for example, we applied these different comparison methods. If you want to send the data that is of, for example, if you want to send the data that is of large size, and we want to reduce that data, after reducing the data, we send the data from user A to the user B, for example. So then we apply the comparison methods. So this method uh, is applied on some message, and it produces the message from that is actually is using some method which is having different steps which are applied. Like for example, it uses different 16 different steps are applied on a particular message, and then it creates some the value or the message which would be the compressed message, and then we can send that message from user A to user B. For example, uh, we have this figure further explain about this, that we have a message having different parts, like for example A, B, C, and D. And we have a value that we have a message, and for example A, and we have a message that's a B and C and D. For example, we calculated a greatest common divisor from B and C and D, and then we exclusive OR with the A, for example. Then it creates a message from that. Then we again exclusive OR that with the value of A, for example, and then we apply 16 different steps uh, for that. Are 16 different functions or round functions are applied on that message, and when after applying these different 16 round functions, we can permute the data, or we can exchange the data between A, B, and C and D. For example, A is exchanged with a B, or B is exchanged with a C, or C is exchanged with a D. So this function is actually called as a permutation. So where we apply different functions which are applied for the data, for example, which is exchanged between user N and user B, and when it is applied on that, so it creates a message or that creates a hash value from that. So when it creates a hash value from that, so that hash value which is compared with the message, original message. So if it is the same, that means the data is not being modified or the data has not been changed. So I also send you the lecture slides as well.